This video is reviewing linear graphing from your previous work, just to see if you can remember it. And these graphing methods are not a table of values. We're well and truly past that stage. Once we look at the two methods for graphing linear functions, we're going to then do some problem solving. So basically, you'll remember that a gradient is the slope or the steepness of a line and its rise over run, and the symbol for gradient is often m. So m is rise over run, and the gradient is the change in y per unit change of x. So it's comparing how y changes when x changes. If y changes a lot compared to x in a positive way, that would be a steep line. If y goes down compared to x, it would be a negative gradient. So it's like the rate of change of y compared to x. And there's a diagram. So we've got rise, we've got run. We've also got the intercepts, y-intercept, where the graph cuts the y-axis. And then we have the x-intercept, where the graph cuts the x-axis. It's very important to remember and understand that the y-intercept happens when x equals 0. You can see that there. And the x-intercept happens when y equals 0. And as I said, the intercepts are where the line crosses the axes. So basically, the intercepts are 2 points. Alright, so these are points, which is handy to remember. So I've just made up a couple of questions here. We'll look at this one first. So graph y equals 4/3 x minus 2. So it's a linear function, it's a straight line graph. First thing we need to do is identify the gradient and the y-intercept. The y-intercept is -2 and the gradient is 4/3. So we write that information in. Writing down that key information. So gradient is 4/3. Y-intercept is -2 because it's plus -2, and that comes from what you should know really well by now, y equals mx plus c. So then we're ready to graph it, because you only need two pieces of information to plot a linear graph, and the two we've got here is gradient and y-intercept. Now the y-intercept is a point, as I mentioned, so if we had -2 down here, we've got a point. Now what do we do to work out where another point is, or where to go from there? Is we use the gradient. The gradient is rise over run. So we simply rise 4 and run 3 for each point. So 1, 2, 3, 4, and then 1, 2, 3. Which will get us the next point. It's better with a grid line, a grid paper, but basically we'd have another point there. We only need 2 points, and get a ruler, not like what I'm doing with my tablet, but if you get a ruler, make it nice and straight. Voila, we've got it. Now what would that other point be? And you only need 2 points, you can extend it out from there. So that would be 2 up there, and of course 3 across, so it's the point 3, 2 is the other point. We've got this straight line. Next one here, we've got 2 pieces of information. We've got 2 points. We've got the x-intercept and the y-intercept. So if the x-intercept is a given feature and it's 5, we can write that as a point. So the x-intercept happens when y equals 0. So it'd be 5, 0. And the y-intercept happens when x equals 0. So that would be 0, 3. And we have 2 points. So we get our graph. Okay, 1, 2, 3, 4, 5. We've got 5, 0, which would be a point here. Of course, it's on the x-axis because it's an x-intercept, and then the other point on the y-axis because it's the y-intercept. 1, 2, 3, and then we have 2 points. That's 2 bits of information. That's all we need, and we connect those up. And please use a ruler. I'm using a tablet, so it's a bit tricky for me. But if you use the ruler, it'd be a nice straight line. Problem solving now. So we've got a 90 litre full tank. It begins to leak at a rate of 1.5 litres per hour. V litres is the volume of water in the tank, and T is in hours. Write a rule for V in terms of T. Okay, so V depends on T, so it's V equals. We start with 90, and then the tank is leaking, so it's 90 minus 1.5 litres per hour, so that's 1.5 times the number of litres, the number of hours I should say, so that would be 1.5 T. And makes sense because after 1 hour we would sub in T equals 1 there. After 1 hour you'd lose 1.5 litres. Okay, so that's your linear function, and it is a linear function. It's y equals mx plus c, because you could rewrite that if you wanted to like that. And remember, it doesn't have to be y and x. We've got v and t are the two variables. Okay, and you know, if you wanted to look at it rise over run, it would look like that. They're all optional steps. That's the main answer there for A. So we could sketch the graph, and then we could find the rule using the steps from above. You would use the methods from earlier in the video to do part B. One thing here, we've got a restriction on time. We call that a domain, restricted domain, D-O-M-A-I-N. And why would it be restricted? Well, time can't start before time equals 0, because we'd be putting water in the tank. That doesn't make sense in this problem. And it ends here at 60. Why do you think? Well, what's 1.5 times 60 is 90, so 90 take 90 is 0. That's when the tank's empty. So the rest of this here down here is actually should not be graphed at all. So when it hits 60, it's 0. And then you'd be able to find your rule to find the volume of the water after 5 hours. You'd sub in T equals 5 in there, and basically we can do that nice and quickly here. C part 1, we've got V equals 90 minus 1.5 times 5. Sorry, that's a 5, which is 75. 7.5 I should say. And 82.5 litres is left. Lastly, if we want to find the time taken to completely empty the tank, well, we've already mentioned that there. It's 60, isn't it? Because 0 equals 90 minus 1.5 times how long, T, solving the find T. So we've got 90 equals 1.5 T, and T is 90 divided by 1.5, and that is 60. Or checking 60 times 1.5 is 90, so that works.